In section 16.2, we're going to talk about how one group of people could represent multiple populations depending on the question that you're asking. So recall that a population is the entire group that you are studying. So when you analyze a group, you usually have a question you want to answer about that group, and one example could be how many students at Worthingway play sports. So the students at Worthingway would be the population. Sometimes you want to compare two groups or two parts of a group. An example question would be, are students at Worthingway who play sports generally taller than those who don't? So the two populations would be those Worthington students who play sports and the Worthingway students who don't play sports. And sometimes you're asked a question that requires multiple populations in that same group. So an example question would be, which sports athletes at Worthingway have the highest grade point average? So the populations would be each individual team or sport at Worthingway. So down here it says a teacher gave a test to each of our 3 math classes. To answer each question, should the teacher consider the classes as 3 populations or as 1 population? So I would like for you to pause this video, write either 3 or 1 next to each question, and then unpause to see if you were correct. Alright, so you should have gotten 133, 313. If you have a question on any of these answers, please ask me. The next scenario, the school nurse tested the eyesight of all the students in grades 6, 7, and 8. To answer each question, should the nurse consider the grades as 3 populations or as 1 population? Again, I ask you to pause and answer the questions, and then once you have answered, check to see if you were correct. So pause the video now, and you should have chosen 1, 3, and 3. Again, if you have any questions about those answers, please ask me. Moving on to the next page. A researcher is analyzing United States Census data. A census is a survey asking every individual in the United States questions. It happens every 10 years. For each question, how many populations should the researcher use? Describe the populations. So in this one, you're answering with a number, how many populations, and then after you answer with the number, then you are writing what each population is made up of. So pause the video, try these on your own, and then when you have completed each one, check to see if you were right. Pause the video now. Okay, so to check your answers, you should have gotten 2, the people in Hawaii and the people in Maine, 3, people in Chicago, LA, and Philly, 1, people in the United States, and 50 people in each of the 50 states. The next question, a scientist is analyzing sea urchin samples taken from the ocean. For each question, how many populations should the scientist use? And describe the populations. So again, I'm going to ask you to pause the video, answer the questions, and then check to see if your answers are correct. Pause the video now, please. Okay, you should have gotten 1 for the first one, and the population is all water where sea urchins live in the entire world. The second question, you should have gotten 7, water off the coasts of each of the 7 continents. And in the third question, you should have gotten 2, water in the Atlantic Ocean and water in the Pacific Ocean. Alright, the next part of your notes explains what inferences are. And you can make inferences about populations using random samples. Over here, you can see that we have the definition of an inference. When you make a judgment by interpreting a set of data, you're making an inference. And more specifically, we're talking about comparative inferences, and that's an inference that compares 2 things. So if you look at the diagrams here, population A and sample A, population B and sample B, you can see that an inference for population A is based on the sample A, 65% of population A loves to sing. An inference for population B would be that 30% of the population B loves to sing. Now, if you look over here, sorry about my dogs, if you look over here, again, if you look over here, comparative inference would be comparing the two different populations. So based on the samples A and B, a greater percent of population A loves to sing than population B. So you can make an inference about each individual population, and then you can make a comparative inference comparing the two different populations. Let's take a look at the next page. So here, I'm going to ask that you take a look at the data given and make a conjecture about why there are two peaks in the dot plots of both samples. We're talking about lengths of fish in two different ponds, pond A and pond B. And based on your conjecture, you're going to make a comparative inference about the fish in the two ponds. So, I would like for you to pause the video, write your thoughts down, and then compare your thoughts with what I write down in just a moment. So please pause the video and write down your thoughts. Okay, so these are the ones that I came up with. That does not mean that yours are wrong if you came up with something different. But my conjecture was that there could be two peaks in the size of the fish in the ponds because there's a large group of adult fish and another large group of young fish. So the adult fish will be larger and the young fish will be smaller. So we have adult fish and we have young fish. Okay, just make sure that you realize that we are talking about the same type of fish. They're koi. So you would not want to say that there are different types of fish in the ponds. The comparative inference, I would say that if I look at the peaks, there are two distinct groups in pond A, and in pond B, they're more closely related in terms of length. So I said that in pond B, the fish are closer together in age than in pond A, since their sizes are more consistent than the fish in pond A. Again, if you would like me to check your conjecture and comparative inference, please bring it up to me and I will see if you're on the right path. All right, let's take a look at the next one. It says that the table shows the number of hours that a random sample of students in two classes spent on homework last night. So we're just talking about one night. Make a conjecture about why there are two peaks in the dot plot of class A, and based on your conjecture, make a comparative inference about the students in each class. So you see that there are two distinct groups in class A, but in class B it's more consistent. Please pause the video and make a conjecture about why there might be two separate groups in class A, but one in class B. And based on your conjecture, make a comparative inference about the students in each class. Pause the video now, write your answers, and then compare your answers to mine. Alright, so I said that since Class A had several students who spent 4 or more hours on homework last night, they may have had a big project or test due today, and they did not plan ahead for it. But some students in the class had worked on it prior to last night, so they did not need to spend as much time on it. My comparative inference, if you look at Class B, there was nobody who spent more than 4 hours on their homework, and about half the class in Class A spent 4 or more hours. So I would say that due to that, Class A did not plan as well as Class B. So I'm going to say that Class B has better time management skills in general than the students in Class A. All right, let's take a look at the next one. This is where you're doing it on your own, and you are going to put your answers down on paper, and then after that, sorry about that, after that you're going to put it into a Google form. Okay, so once you have your answers written on paper, you need to go to bit.ly/AM16-2. Again, the AM stands for Accelerated Math, and the 16.2 is the section that this is. So, answer the questions on paper, go to that website, and put your answers into the document.